Hello and welcome everyone. Our today's question is palindrome pattern. So by looking at the difficulty tag, it is hard, but I must say this question is pretty easy. By looking at the tag, I thought I will solve this in morning, but why not just give it a try at night? So if you look at this question, we have an array of n cross n, and we have to tell which row or which column is a palindrome. So we have to prioritize row over column, and we have to prioritize lowest index over greater index. So first we travel in low row wise. So we have this row number 0. So this is not a palindrome, and row number 1, this is a palindrome. So we have to return index and whether row or column. So we have written R. In this case, this is not, and then we have to traverse column wise. So this column, 0th column, is a palindrome. So we return 0 and then see if nor row or nor column, if not row, if row or column, either none of them is a palindrome, so we have to return -1. So let's go to the, so let's build the approach. So first we have to travel row wise. So row. So I made a function row traversal. So first I will pass this row, then I will pass this row, I will pass this row. So I will pass ith row, or I can say R. Then we have to pass column wise. So I will traverse in this manner, in this manner. So I will pass C. So first we have to traverse row wise. So I will pass this row. First we have 0th row, and we have this array. So I am not building an array, I use the pre-built array. So in this row we have a pointer L pointing to 0 index and R pointing to n-1 index. We will check this value. If this value is equal, then we shift our pointers. So in this case it is not equal, so we will move to next row. So I will pass row number 1. So in this case we have L at 0 and R at n-1. So we will check this value, and this value is equal. So I will increment L and decrement R. So as you can see, both pointer pointing to same index. So value must be equal. So we will return true. So here the answer is 1R. Let's go to the next test case here. So we have row. First I will pass 0. So we have L at 0 and R at n-1. So we have to check array of row number. This is row and column L. So it must be equal to array of row number and R. So I can say it is row. So here row and here row number and R. So row, first we have row as 0. So row 0. So it will check 0 and L 0. So 0 value, and it will check 0 and n-1 means n is 3, n-1 is 2. So 0 2 this value. So it is not equal. So we can say this row is not a palindrome. So we will pass next row, row number 1. Row number 1. So here row number 1 and here row number 1. So it will check 1 0 and 1 2. So these values also not equal. So we will pass next row. So row number 2. So now 2 0 and 2 2. So this and this, it is not, it is also not equal. So we have to travel column wise. Then I have a function column wise traversal. Column, I will pass C as column, and here also first I will pass 0 and I have to pass till n-1. So we have a loop for that. Inside we have to pass a column, ith column. So first 0th column is passed, and in the column wise we have same approach, L pointing to 0 and R pointing to n-1. So here first column is 0, I will get L and column. So it is a column, and I have to get R and column. So first L is 0 and column is also 0. So this value 0 0 and R is 0, row number 0, and column is 0. sorry, row, so it is r. R means n minus 1, so it is 2. So 2 0. So 2 0 this value. So yes, it is equal. So then we have to increment our L and decrement our R. So next it will equal. So L is pointing to 1 and R is pointing to 1. So both value pointing to same index. So we can say this row is a palindrome and we have to return 0, then C. So we have to return ith row. So I, then C. So that's the overall approach. Let's jump into the coding part. So it is a n cross n matrix. So n. Then we have to traverse row wise. So it is for a row. Check if ith row is a palindrome or not. So we have a function row palindrome. I am passing row and n and a. So then just check whether this row is a palindrome or not. So L and R pointer. So row number. So this row and L. Then if its value is equal, we have to increment our L and decrement our R. If not equal, we have to return false. This row is not a palindrome. If L is greater than or equal to R, then we have to return true because this row is a palindrome. Now, if row is not a palindrome, we have to check for column wise. So we have a loop for that column. Check if ith, this is column, is a palindrome. So we have a palindrome column function. So here same function apply. So but here we have to check for column. So I am passing column on the second value. So we have to check for column. So if it's equal, then we have to return true. So it will return ith column. Else neither row nor column is a palindrome. We have to return -1. So this solution will work fine. Let's talk about the time complexity. This for loop will run for n, and here row palindrome, it will run for n by 2. So overall it is n cross n by 2 plus n cross n by 2. So we can say n square by 2. Overall it is n square and space is constant. So we have meet the expected time and space complexity. If you are watching till now, consider subscribing, would be appreciated, and thank you all for watching this video.